sorry about the lack of preparation. My colleague was supposed to present this talk in the virtual world, so I'll have to practice this already. Just present very briefly some results that we obtained on analyzing the ability for a MMO backend service to be deployed on cloud services in this case. We had a similar talk in NOSDAP the first day on deploying Dash servers for video streaming towards cloud backend. We're doing the same, but then for MMOs in this case. So the goal, in general, was to create a dynamic and scalable, cost-effective backend, but then move it towards the cloud instead of having it on a private infrastructure. You can all have a look at the data that has been generated within this project. It's all freely available on this website. As part of the project, we developed our own custom architecture that is able to be deployed on such cloud services, and it is intended to be very scalable. So we have various EC2 instances. For example, we used Amazon mainly as our benchmarking platform. We have certain services that they have a regulation of the streams going on between the different clients and the different servers. And then we have starter instances, for example, that regulate everything that's going on within Amazon instances. Major selling point is that when you're moving towards the cloud, there is a lot of dynamics involved. So the cost models can change at any time. Some provider might offer you better options in terms of bandwidth, for example, versus processing power at different points in time. You have to be very dynamic in how you assign different servers to different cloud providers. So really, you'd have to have multi-cloud provider support in there, and cost optimization depending on, for example, the service level agreement that you can get with the different providers, different instance types, the cost model, etc. To really try to prevent vendor lock-in. So that's one of the main selling points of the architecture that we propose. Also, a general remark is that moving to the cloud is in general always proposed as being cheaper than running your own infrastructure. Well, it's not necessarily so, because if you keep everything running on the cloud, it costs you more or less the same as a private infrastructure. It's only when you can really dynamically determine what resources are needed, and if resources are no longer needed, if you can turn them off dynamically and switch them on, really in a very cost-effective way, then you can get the cost reduction. So it's very important to note here. To kind of illustrate that, we took a look at different benchmarks that we ran in EC2, different instance types that they had available. First thing is that we take a look at how long does it take for a new instance, for example, a server to become ready for the clients to connect to it. And then we took a look at how does it perform, for example, over the entire duration of the day, for example. So does it really matter at what time of day you start at the new instance? Is it quicker, for example, in the morning versus in the afternoon? And what is the variability of that data? For example, you can see here that there is some variability. Sometimes it takes about 200 seconds for a new instance to become ready for clients to be connected to it. Sometimes it takes over 5 minutes in this case. But there are some outliers here where it has taken nearly 10 minutes, for instance, to become ready. So it's not really something that you have much control over, but it is very important as a metric to decide on when you need to actually instantiate new servers on cloud infrastructure. We also took a look at handovers. Why is that very important? Well, if you have different servers going on, then you need to move clients between servers. If you want to have a cost reduction and you want to concentrate all of the different clients on the least amount of servers that you can actually provision within the cloud provider's infrastructure. Then we took a look at how long does it take for a client to move between one server and the other. And we investigated that, for example, using only Amazon servers, so moving within the same data center from Amazon, moving between different Amazon data centers, for example, in Europe and the US, for example, which is the purple one, which you noted here. We also compared that to a private cloud infrastructure. So we set up a cloud stack infrastructure and on premises. We compared the different findings between Amazon and our own cloud infrastructure. And even Amazon is even better in this case than our own private infrastructure. So it's really no problem at all for practical deployment, because handover times are typically, as it says here, below 2 seconds. You can also have the kind of thing that is shown here, for example, handover durations versus redirections, etc. I'll leave that up to the audience to have a look at the data that's present in the URL that I proposed in the first slide. Taking a look at the different cloud instance types that you can get. For example, you can get different propositions from Amazon. Like a micro instance is much cheaper or even free in that case, versus, for example, a medium instance or a large instance. So what we investigated is it really worthwhile to invest in a large instance? Does it really have an effect on the amount of clients, for example, that you can really support with your game server that you're running on Amazon? Here we can see that there is definitely something to it. For example, if you take a look here, these are the micro instances provided by Amazon. What we did here, we ran a simulation where we, in terms of time, every 10 seconds we added new bots towards the system. So we had automated players that were added to the system at certain intervals, 10 seconds each time. And you can see that with increasing time or the increasing amount of bots in the system starts degrading in this case. For example, the red line is the frames per second that you can get using our viewer. You can see there is a real drop in that case. It's much less pronounced in the cases of the medium instance, for example, here, or the large instance, where you can get much better performance, but there is really not that much between medium and large in this case. So it would be a very big trade-off to check do I really need that extra power for the large instance instead of the medium instance, because they are much more expensive. We also took a look at the networking performance of different cloud providers, and here we can see that okay, it's quite stable. For example, this is between Amazon servers within the same data center, the same EU data center, for example. It's quite exaggerated here because it's like in terms of microseconds here. It's shown. Also in terms of internal versus external bandwidth availability, it's quite stable, so you can get quite stable delay times. The throughput is dependent on the type of instance that you choose. For example, if you have a micro instance, the throughput is a lot lower in practice than if you, for example, choose a large instance on EC2. So if you have lots of data being transferred between servers or between servers and clients, for example, you would be better off choosing a large instance versus a micro instance in this case. We also ran some tests on OpenSim to have comparison on not only your own system on Amazon, but also OpenSim running on Amazon. Also for the micro instance, the small instance, and for example the large instance. And you can see that, okay, performance really starts dropping if you add lots of clients, because you have lots more clients here. For example, the red line is the amount of clients that are being introduced into the system. And then the other system gives you an idea about the delay and the performance of the system. So it really starts to break down in terms of performance with the micro instances, but with the large instances there is no actual performance decrease. Same thing can be said for the latency, for example. As we start introducing load on the servers within a micro instance, for example, small instance or a large instance, you can see that with the micro instance, the delay starts increasing and starts varying widely. So that's not something that you really want on a cloud backend for an MMO. It's quite stable for the large instance in this case. Okay, that's basically what I wanted to tell you. So if you have any questions, I'd be happy to answer.
Any questions for Peter? Yeah, I can make a comment that the latency delay between Europe and America might not be that much different, but I can tell you there's a large difference when you're connecting from Africa up to Europe or up to. We've done some experiments where we migrated from one server in Amazon EC2 to another server in Amazon EC2 while they're connected from Africa, and then the delay becomes a bit of a problem for you there. So my question, apart from that random comment, my question is, so you mentioned that the Dash server that they're also moving to the cloud. So what you would say is what's the biggest difference between doing the multimedia content pushing versus doing the MMO, and what do you think is the biggest challenge that has to be addressed?
Well, mainly if you look at the Dash streaming part, it's mainly getting the content from the server to the client. So it's really no uplink involved in that case. So it's like just a GET request that you need to do for getting the Dash stream going. In case of the OpenSim, for example, you also have these, or an architecture in that case, you also have inter-server interactions, where there's interactions between the servers themselves. Something that you don't have in Dash, for example. It's just like you put the video on the server and it just stays the same all the time. Here it's a really dynamic system, so it changes all the time. You have different servers that are supposed to interact with each other, for example. That's not present with the general multimedia server. So that's the main difference.
Sorry, do you have any other questions before I Do you have any idea of the type of inter-server traffic that is being generated, and how much? I mean, is that a portion cost-wise? Is it a problem bandwidth-wise between the servers? And
well, not really cost-wise, because most of the time it's really cheap, so or even free in that case. So if you have different streams going on between servers on Amazon, for example, it's mostly free, so you can just exchange any data you want for that for free. If you look at external connectivity, of course, it might become a cost factor in that case, because like that you have to pay for, of course. With some providers, there are some providers that even give you some external benefit for free. So it's really important to choose the right one for the right job. That's really the that we want to do address here.
Okay. No other questions? Okay, let's thank the speakers again.